when you use a theorem, you have to, and you're going to use it in your explanations. Okay, you're going to argue yes or no based on theorems. But if the theorem requires something to be a function and something to be continuous, you have to explicitly state it when you're writing. That's part of the requirement because the function is continuous. So you just said the word function and you said the word continuous. So I checked the check boxes like, yep, you got those two things. The next part is, and because the points are either on the same side or on opposite sides of whatever axis you're trying to cross. Doesn't have to be the x-axis. It can be any horizontal line that you're trying to cross. So you're going to make an argument based on whether or not the points you're looking at are on the same or opposite sides. If they are on the opposite sides, you can guarantee that the function will cross that axis once and maybe more than that, but at least once. My examples cross multiple times. Everybody else has crossed once, but nobody's crossed none. It's one or more. You're guaranteed they have to cross. That is the basis of the intermediate value theorem. And you can cite it as the IVT. It's fine, like on AP exams and stuff, you may cite the IVT, but you have to state the following things. So make sure you circle or highlight them. You have to state that you're working with a function. You have to explicitly state that your function you're working with is continuous. You have to specifically state what interval you're working on. And then you have to check f of a and f of b. Those are the values of the points you're working on. If the f of a and the f of b, those are the y values, if they are on the same side of whatever axis you're covering, then the IVT guarantees nothing. If they are on the same side, there is no guarantee of crossing anything. You can avoid crossing it. But if they are on opposite sides, if the axis is between, which is the word intermediate, means between, if they are on opposite sides, you can guarantee a crossing at least once, and if not more than once. Here's, this is an example, but I thought it was better if we drew our own examples. Okay, going from point A to point B, this value here is in between them. It is impossible to avoid that going from one to the other because A and B are on opposite sides of that line. So no matter if we're talking about the x-axis or any other floating horizontal line, if your endpoints are on opposite sides, it's impossible to avoid it. Here's another example. Maybe 3 times you cross, but the guarantee is that at least one time that you will cross. All right, here is why. It's because you can't have jumps or separate branches. Okay, Isaac was trying to avoid it by making separate branches, separate pieces, but then that violates the fact that it's going to be a continuous function in the first place. Okay, it cannot have any breaks. All right, here's what a question might look like. Here's a table. Here's some points on, and notice that it says the key words. It says function values and it says continuous. So we've got the ding, ding, ding words there. Great. Okay, now the question. Does there exist an R somewhere between 0 and 2, that's my interval, where the function would equal 5? In other words, it's asking you, can you avoid 5? Is it possible to avoid 5 in this question? All right, so then you're going to check. Well, if I'm working on the interval 0 to 2, I need to check what f of 0 is. And according to the table, what is f of 0? 7. And then I need to check what f of 2 is. And according to the table, what is f of 2? And because this is continuous, 7 has to connect to 3 somehow. Is it possible to avoid the number 5? No, because when you're connecting 7, which is up here, to 3, which is down here, there's no way to avoid crossing through a horizontal line at 5. You're going to have to cross it at least once. You might cross it more than, but does there exist some R? And the answer is, notice they're not asking you to find the R. The question is, does it exist? Does R exist? Okay? It would be like me saying, okay, Andre, how old are you, 17? Okay, so at one point in Andre's life, he was 0. Andre is now 17. Would it have been possible, although he may have liked to avoid it, would it be impossible for him to avoid the 13th year of his life? Okay? No. Your life is continuous. Okay? We're not, and your timeline is continuous. You could not avoid middle school. You were 13 at one point. Okay? Everybody in here was. That's the idea. So, when we give a reason, we say, because f of x, there's function, is continuous. Okay, so I've said function or written function, and I've said continuous. And since f of 0 and f of 2 are on opposite sides of 5, the IVT guarantees G of R will equal 5 somewhere. At least once. Maybe more than once, but it guarantees it will equal at least because they're on opposite sides. That's the intermediate idea. Let's try another one. Let K be a function defined by the following. Whoops, I forgot the bracket on your notes. Would you mind adding that so this is a piecewise function? Okay, what are the two different pieces here? What are the shapes? Line connected to, or line and line, okay? Must there exist some x between 0 and 2 for which k of x is equal to 4? In other words, can you avoid 4? Is it possible to avoid 4? That's what they're asking. So what should we check? All right, he wants to check k of 0. All right, what is k of 0 according to that piecewise function, Andre? You wanted to check it. 2. Okay, and he said check k of 4. All right, what is k of 4 according to that equation? 8. All right, in your esteemed, most humble opinion, is it possible to avoid the number 4? He says no. Everybody agree with him? I was hoping somebody wouldn't.
Isn't it 0, 2 has 0, 4?
Oh, I'm sorry. Yes, that's the first thing we got not right. Let's check 0 and 2. All right, Andre, back to you. 6. Is it possible to avoid 4? He says no. I'm still hoping somebody disagrees with him. All right, what are the requirements?
All of it has continuous.
Oh, it has to be a function. Do I have the keywords?
Yeah.
Okay, let K be a function. So it passes the vertical line test.
Oh.
But does it pass the continuity test? Or is it broken into pieces like Isaac's picture here? Okay, so let's check. Is it continuous? Okay. Where might it not be continuous? At 1. All right, let's check. What's the limit coming towards 1 from the left? 3. What's the limit leaving 1 from the right? 5. Ooh, is that continuous? What kind of discontinuity? That's a jump or a gap. There is a gap. 1 ends at 3, the other starts at 5. We just avoided the number 4. Because we ended one of them at 3 and the other one started at 5, but it's not continuous. Okay, so you gotta check that first. Since k of x is not continuous at x equals 1, the IVT doesn't apply and guarantees nothing. Okay, that would be me saying, oh, by the way, surprise, time isn't continuous. You can, jump around in time all you want. Okay, you've got the time stone, the infinity stone. You can jump around. Okay, let's try another one. All right, you're looking for the keywords. Let f be the function. All right, good, good. I've stated that's a function described by the equation x squared minus 4x plus 1. Show that there might be a solution in the interval 0 to 1. So a couple things we have to understand here. What do we explicitly need to investigate first?
Continuity.
Is it, okay, what kind of equation are we dealing with? All right, what do you know about parabolas? They're continuous, okay? So, since f of x is a parabola, it is continuous. All right, that means I can move forward with the IVT. The next step would be checking the function values of the IVT. So then we check f of 0 and f of 1. All right, who's got f of 0 for me? It's the fastest thing you can figure out. 1, thanks. Who's got f of 1 for me? -2. Okay, what are they opposite sides of? These two things are on opposite sides of what? What line? X-axis. Okay, they're on opposite sides of the x-axis. One is positive, one is negative, which means it's impossible to avoid the x-axis. What happens when you cross the x-axis? What is that called? Well, yeah, but what's the name of the thing where you cross, like if I told you this was the x-axis, what is this called? An x-intercept. What's another name for an x-intercept?
Zero.
A zero. What's another name for that? A root. The root and a solution. All of those things all mean the same thing. We've got all of them. We can call this an x-intercept. We can call it a root. We can call it a solution. We can call it a zero. All of those vocabulary words mean the same thing. So, show that there is a solution. Okay? So, because the IVT will guarantee, let's see, because f of 0 and f of 1 are on opposite sides of the x-axis, and because we already said it was a function and we said it was continuous, then we can say the IVT guarantees a solution between 0 and 1. This is what your graphing calculator does every time. You know how your graphing calculator, when you do calculate 0, your graphing calculator asks you to do two things first. You know how it asks you like what the beginning of it is going to be, and then it asks you what the next number is going to be, and those two things have to have opposite signs. One of the things you give it has to be a positive number, and one of the things that you give it so that your calculator knows I just went from one sign to the other, there has to be a 0 in between. So look here. It's literally what your graphing calculator is doing when it's asking you that. Okay, last one. Maybe I have 2 more. We'll see how many I get. Okay, same equation, same parabola. I want you to find another interval where you're guaranteed to have a solution. So what else do you need to find? We just went from 1, which is above the x-axis, to -2, which is below the x-axis. What do you know that parabolas do? They're going to turn around and go back up. So now I need you to find me another value that shows that it went back up again. Okay, so we already have f of 0 equals 1. We have f of 1 equals -2. What do I need to find after this? Another positive number. Okay, what do you want to check next? F of 2. All right, what is f of 2? 2 squared minus 8. Okay, I get -3. Okay, so still not enough. What do I need to check next? Check f of 3. Okay, did I get it? F of 3, 9 minus 12 plus 1. No, f of 4. Okay. So where is it likely, where are we guaranteed that there's going to be another solution? Between, well, even closer, between 3 and 4. So because f of 3 and f of 4 are on opposite sides of the x-axis, and because we're already a function and we're continuous, the IVT guarantees a solution, another solution, between 3 and 4. All right, last one. Find a solution, an interval A and B, A to B, where the cubic equation is guaranteed to have a solution. Okay, you know this is a cubic. What do you know about cubics? Yeah, they're this. So what can you safely say about a cubic?
They're continuous.
Oh, even before that.
Oh,
It's a function, okay? The cubic is a function, and a cubic is continuous. What additionally you want to do is make sure that you set this equal to 0. All right? You want to make sure that you slide that x over to the other side. So now all I need to do is find some numbers that are on opposite sides of the x-axis. And then I'll be able to guarantee that it has a solution. So we just need to start experimenting. Okay, I would always try f of 0 first because that's the easy no-brainer. If I plug 0 in for x, I'm going to get 3. I just need to find another number. Does anybody have one for me that's going to turn out to be negative? Like, is it going to be f of 2? Will that work? That's 8 minus 2 plus 3. I get 9. So it's not that. Find me one. Come on. Smartest kids in school. Negative f of negative 2. What do you get for negative 2? Okay. All right. So Matthew, you're going to say that you're going to guarantee me a 0 between where and where? No, that's not how we say it. We don't say 0, negative 2. We say negative 2 to 0. Negative 2 comes first. 0 comes. All right, so Matthew wants to guarantee it's going to be between negative 2 and 0. Anybody else want to make a different guarantee? What's f of negative 1? I'm just curious. That's also 3. Okay, so what does that tell you? It's not just between 0 and negative 2. What is it between? Negative 1. Negative 2 and negative 1. You can shorten your interval. Okay? I just went from an interval that was 2 units wide to an interval that was 1, which is even better. Okay? So I just narrowed it down a little bit. Okay? All right. That